Hello, and welcome back to Summarize Science. Have you ever seen those incredible videos of humanoid robots performing complex tasks and wondered how they learn to do it? A common approach is to have them imitate human movements, but it's not as simple as just copying and pasting. Today, we're looking at a new system called OmniRetarget, which introduces a groundbreaking way to teach robots by preserving the most important part of any action, the interaction. The core challenge is that robots and humans have very different bodies in terms of shape, proportions, and joints. Directly transferring a human's motion can result in physically impossible movements for the robot, like feet sliding on the floor or a hand passing straight through a box it's supposed to be holding. Previous methods often struggled with this, producing glitchy reference data that required a lot of manual cleanup or complex reward systems to fix. OmniRetarget tackles this by creating what's called an interaction mesh. You can imagine this as a 3D web connecting key points on the human, any objects they're using, and the surrounding environment. The system's goal is to transfer the motion to the robot while deforming this web as little as possible. This ensures that the crucial spatial relationships, like how far a hand is from a box handle, are preserved. At the same time, it enforces hard physical rules, so the final robot motion is always kinematically feasible, avoiding collisions and other weird artifacts. But here's where it gets really powerful: data augmentation. The researchers can take a single human demonstration, like climbing a platform, and automatically generate tons of variations. They can change the platform's height, the size of an object the robot is carrying, or its starting position. For each new scenario, OmniRetarget solves for a new, physically correct motion, creating a massive and diverse dataset from just one recording. This solves a huge data bottleneck and makes the training process much more robust and efficient. And the results are nothing short of stunning. Thanks to this high-quality data, they trained a policy that allows a real Unitree G1 humanoid to perform an entire 30-second parkour course. This includes carrying a chair, using it as a step, vaulting over a barrier, and even doing a parkour roll to absorb the impact of a jump. What's more, this was achieved with a very minimal and simple reward system, and transferred directly from simulation to the real world without any additional fine-tuning. When compared to previous state-of-the-art methods, OmniRetarget's generated motions were significantly better. The quantitative results show far less body penetration and foot skating, which directly translated to much higher success rates when the robot policies were trained and tested. So to recap, OmniRetarget is an interaction-preserving system that generates high-quality, physically plausible motions for humanoid robots from human examples. It uses an interaction mesh to maintain the essence of a task and can automatically augment a single demonstration into a huge dataset. This allows robots to learn complex, long-horizon skills like parkour and object manipulation with much simpler training setups. This is a huge step forward, moving away from patching up bad data and instead solving the problem at its source: principled data generation. By open-sourcing their complete framework, the researchers hope to accelerate progress towards more agile, capable, and versatile humanoid robots that can interact with our world. Thanks for watching Summarize Science.